Yesterday we did the Desmos activity where we looked at a parabola and we started looking at what vocabulary we could use to describe these different events. So now we're just going to make sure we understand each of these terms, and then you'll get a chance to use them. So the vertex, we talked about this term yesterday. The vertex is the turning point, but that's not the term we're going to use. It is the highest or what will be called the maximum or lowest, and then it'll be referred to as the minimum point of the parabola. It is the ordered pair H comma K, and we'll deal with that, what H and K mean, more next unit, but I'm again just because some of this is information just to start talking about it. You may not use all this information in this unit, but we will be talking about HK, and it is on the axis of symmetry. Which is a term we will be talking about in a little bit. The next two terms, absolute minimum and absolute maximum. A lot of these terms have come from just talking about any function. When we are talking about a parabola, there is only one minimum or maximum in the graph, so it is always an absolute minimum or an absolute maximum. So when we're talking about absolute minimum or just minimum in a parabola, it's the point that represents the vertex when the graph opens upward or concave up. When you have an absolute minimum or a minimum, the equation of the quadratic is positive. That's how we're going to get that opening upward or concave up. And at that point, the vertex would be at the very bottom of the graph. It would be considered the minimum. And then the maximum would be the point that represents the vertex when the graph opens downward or what we would call concave down. And here the equation of the quadratic is negative. All right, the next term that comes up is rate of change. Now, we do not have a constant rate of change in a quadratic. That is when we have our linear functions. So when we talk about rate of change in a quadratic or a parabola, we're talking about the average rate of change. Or the ARC. And the average rate of change is similar to finding the slope. You would still find the difference of x values, the difference of y values, but again, you would just be giving an average rate of change. You would not be talking about a constant rate of change. So similar to finding slope. And you actually have two different average rate of changes in a parabola. One will always be a positive and one will always be a negative. Parabola will always have a positive and a negative average rate of change. Increasing over an interval. When we're talking about an interval, in this case, we're talking about something along the x-axis. So when we're talking about increasing over an interval, we're saying for what x values is the graph increasing? For what x values is the graph increasing? And then decreasing over the interval would be for what x values is the graph decreasing? And the vertex would be the divider for when it stops increasing and starts decreasing, or vice versa, if it starts out decreasing and switches to increasing depending on which way the graph opens. All right, so now we have the next word, symmetry. Parabolas are symmetrical. The line that divides the parabola in half is the line or axis of symmetry. The line that divides the parabola in half is the line, in parentheses I'm going to put the word axis because it'll also be referred to as the axis of symmetry. This line goes through the vertex and the line shares the x value of the vertex. So when they give you an axis or a line of symmetry, it'll always be in the form of x equals some number. They're telling you that is the vertical line that is dividing your parabola in half. So you will know half of your parabola will be on the left side of that line and half of your parabola will be on the right side of that line. Positive and negative are going to refer to the equation, which determines which way the graph opens up. Positive means the equation has a positive x squared coefficient. When it's positive, the graph opens upward. Or concave up. So an example would be y equals 2x squared. The 2 in front of the x squared is positive, which means the equation is positive and is going to open upward or concave up. And the negative is the other side of it. The equation has a negative x squared coefficient. The graph opens downward. Or concave down. So an example here would be y equals negative 3x squared. that -3 is going to cause that to be a concave down graph. All right, then the last two terms that we're going to talk about is domain and range. Domain is all the possible x values. When we are talking about a quadratic function or a parabola, there is never a restriction on the x values, so the x values will always be all real numbers. So it will always be all real numbers. And in interval notation, that means, again, since there's no restrictions, it's going to go from -infinity to +infinity. So you would put parenthesis, -infinity, comma, +infinity, parenthesis. That's the interval notation way of saying all real numbers. There is no restriction on your x values. Even though our graph ends at a certain point, it still has other x values possible. Now your range, which is all your possible y values, that will depend on where your vertex is and which way it opens up. So all the possible y values this will depend on the vertex and which way the graph opens up. If you have a maximum, all your y values have to be that y value or below. If you have a minimum, all your y values have to be that minimum y value or above. So we're going to have to look at the graph to determine what our range will be. But again, our domain will always be all real numbers. All right, the next page in your packet they give you a graph. You want to look before you start writing the paragraph that they're asking about. Start marking all the points and everything you know about the graph on the graph before you write that paragraph. So in your group, start talking about things. What's the vertex? What's the line of symmetry? Is it concave up, concave down? Do I have a maximum or a minimum? Start talking about all of those things as a group right now, and then you will have a chance to write your paragraph in a moment. Again, here's the graph that you need to determine all those parts of before you start writing your paragraph and complete sentences. In your group, talk about all the key features. Write it on the graph. What do you know about this graph? So again, I've asked you to identify all of the features before you start writing your paragraph. The first thing we should be identifying is the vertex. This point right here, that is my vertex. What is the ordered pair that is associated with that point? -1, 2, so that's your vertex. Is this concave up or concave down? concave down. So in that case, is my vertex a maximum or a minimum? The vertex is a maximum. It is at the highest point of the graph. The axis or line of symmetry, remember it goes through the vertex. It's always going to be a vertical line. So this line here, I'm going to draw it as a dotted line because you will see that on a lot of graphs. That dotted line is your axis or line of symmetry. And again, it's always associated with an x value. What x value is that dotted line associated with? -1. It's got to be the same x value as the vertex because the vertex is on the axis of symmetry. So we would say that axis of symmetry is x equals -1. Again, the vertex and the line of symmetry have to share the same x value. What about domain? What is the domain of this parabola? What did I say is the domain of all parabolas? All real numbers. All of this stuff that I'm writing on this graph, I expect you to be writing on your graph in your book. Which again, in interval notation would be -infinity, positive infinity. Now, the range does have restrictions. The y values can't go above what number? 2. It can't go above this y value. This is the highest y value I can have. The graph all is below that value, so my range I could say y is less than or equal to 2. And how I could write that in interval notation. If it's y is less than or equal to 2, that would be -infinity, 2, but that would be a bracket next to the 2. A parenthesis means it's not included in the answer. A bracket means it is included. Infinity is never included, neither positive or negative. That will always be a parenthesis. But if we're saying that y can be equal to 2, in interval notation, we're using that bracket. The bracket means it's included in. And then the last part that you could talk about here is when is it increasing and when is it decreasing. And that's as simple as this side of the graph is moving up as I move from left to right. This side of the graph is moving down as I move from left to right. So increasing it's increasing from -infinity. Again, intervals, we're always talking about the x-axis. So it's increasing from -infinity to -1. So -infinity is less than x is less than -1. In that range of x values is when that graph is increasing and it is decreasing from -1. Now the vertex is not included in the increasing or the decreasing. That is what we said yesterday was that turning point. So the decreasing is -1 is less than x is less than positive infinity. So again, that axis of symmetry is going to be that dividing line for your increasing and decreasing. And again, depending on which way it opens up. Now you have all of this vocabulary to write a description in complete sentences about this graph. You honestly need more than the 3 lines on the paper to describe all of this. So just make sure you're writing a complete paragraph.